those little, I don't know what they're called.
Converters.
Yeah.
USB to serial converter. That's what I use. Because all my GPS output still in serial. A lot of this stuff is still serial port stuff. So if I want to use my laptop, I've got to convert that to serial to USB. But I'm going to talk about serial port because a lot of the equipment out there is still serial port based. What is a serial port? What is a serial port? Now this gets into the serial port basics that you have. What is a serial port? Well, you know, it kind of shows it right there, which is kind of neat. And I'm moving into another area, different area from, I'm kind of leaving this right now. Sprayer stuff. We're done with sprayer stuff. Sorry. Just trying to get out. Okay. So I'm going to talk a little bit about communications, because they say, oh, it sends a signal. Or, oh, it gets my GPS location. Well, how does it get my GPS location into that controller? And it has to do with cabling and wires. Okay, so how do I get my GPS location? Serial port basics. Serial port as opposed to a parallel port. In the old days, we used to have serial and parallel. Parallel meant all the information came through on individual lines. Serial now means that the information comes in on one line, one after another. So now the data is coming in where all the data bits, oh my God, I probably got a bit, is like in a row. So I'm coming in, the guy behind me comes in, the guy behind me comes in, as opposed to we're all in a line, and we're all moving together in a line. Into battle. So serial means it's all in a row. How is data communicated? And I send and even today, it just blows my mind how data is still communicated.
Zeros and ones.
Zeros and ones. Magnetic pulses. God, it still blows my mind you still do this. But when you send data, you send it in bits and bytes. Zeros and ones. So you have a, first one you got a 1, and you got a 0, and you got another 1, and you got another 1, and you might have a 0, and you got a 1, and then you got, I don't know how many we have. How many of these do we have? How many bits do we have for a byte? 1,000. It's close. That's like megabits to bits to megabits. 10. Usually 8 for a signal. So this is a 1, 0, 1, 1, 0, 1, 2, 3, 4, 5, 0, 1. Actually, that's a 1 and a 1. Okay? So these are bits, zeros and ones, and this whole thing is a byte. And that's how information is stored. So if I looked at these zeros and ones and I added them up, well, I don't know how to add them up. This is my 1 column, this is my 2 column, my 4 column, this is my, I don't know, how is 8, 16, whatever. And I can add these up and get a number and get some information out of this. All right. The important part about this, now I'm not going to get into computer science here in this class, but information is still sent in bits, zeros and ones, as it comes through. So when I say I get a signal, I'm getting an ASCII signal. It's getting me zeros and ones. And this may be equivalent to a 5, or a 7, or a B, or whatever. You look at assembly language and hexadecimal and all that crap. Look at that stuff. Anyway, so this is how it's sent. But a lot of times, it's also, you have what's called a parity bit and a stop bit. Okay. So when you communicate, interestingly enough, you have a certain format that say, well, how are you communicating? And the way we communicate GPS data coming out of our GPS receiver through a serial port is typically called, anybody know? How the zeros and ones come in? It's called an 8N1. 8N1. 8N1 is the way serial data is communicated most of the time. Sometimes it's not, and it really messes up. Like you get something from the UK or South America, I don't know what system they're using. You got to figure out what system they're using. Just like video, we use PAL and they use NTC, or we use NTSC and they use PAL. Videos aren't compatible. But anyway, 8 means 8, an 8-bit signal, as opposed to a 10-bit signal that somebody mentioned, which is also valid. 8-bit signal, no stop bits, 1 parity bit. Parity bits are just like check bits, I'm sure. I don't know a whole lot about that, but that's typically how the signal is coming in with these zeros and ones, 8N1. So you read some specs on some GPS, it'll say, we communicate 8N1. You go, okay, I'm happy, I'll set my stuff up for 8N1. But most of the time, things know it all works on 8N1. Now, where is that information coming in on my serial port? Okay, I'm getting crazy on you here, but here we go. Just to show you I'm not making this stuff up. Okay, here's where we're talking about start bits. There's my bits. Then we have a stop bit. So we have these 0 through 7. That's our 8 bits. And we talk about 8N1 as our transfer rate. RS-232 is the way we communicate. Okay. Now, where is this information coming in on my serial connector? So if you looked at that serial connector, you saw these little pins coming out, right? How many pins were there?
9.
9. Good, you said 9. 9 pins on a serial connector. RS-232 is the style at which this information comes through. There's 9 pins. 9 pins. And each pin means something. I'm not going to go crazy on this, but each pin means something. And one pin is set up to receive data. Receive data. One pin is set up to transmit data. And one pin is basically my ground. Now, it gets a little bit confusing here, but depending on what perspective you're looking at, whether you're looking at the computer's perspective or the GPS receiver perspective, different pins are for certain things. So, for a 9-pin connector, you have these 9 pins. Transmit data comes in on pin 3, or transmitted data goes out on pin 3. Receive data comes in on pin 2, and pin 5 is ground. Now these other pins mean stuff too.